Last time we talked about the derivatives of the function. Today we're going to talk about some derivative formula that is going to be derivative of constant, derivative of the power function, derivative of exponential function, and derivative of sine, cosine. That is going to be the basic functions that we most use in calculus. So we're going to not use the limit all the time. So we're going to find the formula and we're going to dip them very fast. Okay. So we have fx equal to c is a constant, and if you like to find derivative of the function, from the definition you have limit h go to 0 of fx plus h minus fx over h. So this one is standing for f prime x. So you have limit h go to 0 of c. So this guy is a constant, so it's going to be c, and fx equal to c. So you get limit x go to 0 of c minus c, and c minus c is 0. So this guy is going to be limit h go to 0 of 0, so it's going to turn out to be 0. So we have the first formula that when you dip constant, it's going to be equal to 0. For example, you have the dx of root 3, this guy is 0. The dx of pi equal to 0. The dx of 2 is going to be equal to 0. Let's try negative 2. Okay, so you have derivative of constant is a 0. What does it mean to have derivative equal to 0? It means you're not gonna see any change in y at all. So the function is the constant function c like this. So you get y and x. So you get the constant function c, and you see that the slope of the tangent line to this line turned out to be just the slope equal to 0 all the time. So it's not going to be changing in y at all. So this is what it means to have the derivative equal to 0. It is constant. Okay, so derivative of constant is equal to 0. The next one is about derivative of a power function. When you have fx equal to x to the n, you have fx equal to x to the n, and you like to find derivative of x to the n, so you would want to differentiate x to the n. So you just use the definition. So the definition will tell you that it's going to be the limit definition. So the definition will tell you that it's going to be limit h go to 0 of fx. So it's going to be fx plus h. So it's going to be x plus h to the n minus x to the n. Okay. And on the bottom, you get h. And you see that this guy, x plus h to the n minus x to the n, can be factored as x plus h minus x. So this one will be x plus h minus x, and you're gonna have the factor x plus h to the n minus 1, x plus h to the n minus 2 times x. This comes from an algebraic identity, x to the n minus y to the n. So it's gonna be x minus y, and you have x to the n minus 1, x to the n minus 2, y, up until y to the n minus 1. You don't need to memorize this one, and you don't need to be able to prove this one. Okay, I just show you here, and the thing that you need to memorize turned out to be just this formula. Okay, so let me finish this guy. So you see that the green one, if you simplify, this guy is going to be x and minus x, they will cancel each other. So you're gonna get equal to h, and you're gonna cancel h here and h here. So you be able to get rid of this parenthesis together with this h. So you just have x plus h to the n minus 1, x plus h to the n minus 2 times x, and so on. And you take h go to 0. So h will turn out to be 0. And you see that the first term will become x to the n minus 1, x to the n minus 1, and you have x to the n minus 1, and you have x to the n minus 1 n terms. So you get derivative of x to the n equal to n x to the n minus 1. Okay, so this one will be the formula. Dx to the r equal to r x to the r minus 1. Okay, so we have shown just dx to the n where n is positive integer. However, after we learn the logarithmic function, we be able to show further that for any real number r, we have ddx of x to the r equal to r x to the r minus 1. The way to memorize this thing is going to be you have r come down, okay? You have r come down and you reduce the exponent of x by 1 unit. Okay, so you reduce, so it's going to be x to the r minus 1. So for this one, you have ddx of x cubed ddx of x cubed. So this guy is going to be 3x squared. Let's do this one step by step. So you have, in this case, you have r equal to 3. So you get 3 come down and x to the 3 minus 1. So it's going to be 3x squared. And ddx of root x. So this guy, it is x to the 1/2. Okay, so 1/2 come down and it's going to be x to the 1/2 minus 1. So this guy will be 1/2 x to the negative 1/2. And normally we're going to memorize this thing as 1 over 2 root x. Okay, so you dip root x equal to 1 over 2 root x. Another one is going to be ddx of 1 over x. So this guy is x to the negative 1. So it's going to be x to the negative 1. So it's going to be negative 1 come down. Okay, so it's going to be negative 1 come down, x to the negative 2. So this guy will be negative 1 over x squared. Okay. So here I have like two important stuff for exponential, or not for exponential, for the power function that we normally have during the exercises and during the quizzes. So you have dip root x. Dip root x is 1 over 2 root x, and dip 1 over x is going to be negative 1 over x squared. So let me write them down. So you have dx of root x equal to 1 over 2 root x, and dx of 1 over x equal to negative 1 over x squared. And this one, like I said, it will be important. So let me box them. Try to memorize this thing. It's going to make you stronger during the exercises or during when you do the quizzes. It's going to be making you do them faster. Dip root x is 1 over 2 root x, and dip 1 over x is negative 1 over x squared. Okay, so try to memorize them separately. And you also need to memorize the dx of x to the r equal to r x to the r minus 1. Okay, and you have the number e. Okay, you have the number e. The number e that we're going to talk about is going to be because we're going to study about the exponential function. So let's first introduce the number e first. What is number e? The figure below shows the tangent line to the tangent line, the line that touches the graph only at that point, to the graph y equal to 2 to the x and y equal to 3 to the x at the point 0, 1. And after an approximation, we be able to show that the slope of this tangent line is about 0.7. However, the slope of the tangent line for y equal to 3 to the x is about 1.1. So mathematicians search for the base. So you see that we have the base 2, we have the base 3. Okay. So we need the exponential function that has the base that has the base. So we need y equal to e to the x, and y equal to e to the x is gonna be the base e that has the property that the slope of the tangent line at the point 0, 1, okay, the point 0, 1 is here, the point 0, 1 is here. So the slope of the tangent line at the point 0, 1 turned out to be equal to 1. Okay, so turn out to be equal to 1, and it's going to be useful in the calculation of derivative, and it's going to make the derivative very simple. Okay, so we need the slope. What is the slope here? The slope here turned out to be derivative at 0, right? So this one, because it is x equal to 0, so this guy is derivative at 0 for this function. And this guy will be derivative at 0 for this function. And we need derivative at 0 turn out to be equal to 1. Okay. And it's going to be the number that lies between 2 and 3. So in this case, this is what is I'm gonna lecture first. It turns out that some of the formula of calculus will be greatly simplified if we choose the base a, so that the slope of the tangent line to y equal to a to the x at 0, 1 is exactly 1. Okay. And in fact, there is such a number, and it is denoted by the letter E. Okay, so the letter E here will be denote the base that we're looking for, that has slope of the tangent line. Okay, the slope of the tangent line is going to turn out to be exactly 1. Okay, this notation was chosen by Euler. Okay, so the E come from sometime it's going to be the first letter of his name or the first letter of the word exponential. Okay, so in this case, y equal to e to the x is going to be the function that we're looking for to have f prime 0 equal to 1. Okay, so this guy, you get f prime 0, which is the slope equal to 1. Okay, and the value of e can be approximate correct to 5-digit decimal. It's going to be e about 2.71828. So this e lie between 2 and 3 as we suspected. Okay, so because we have 2, the slope is about 0.7, and for 3, the slope is about 1.1. So our number e turned out to be lie between 2 and 3. Okay, and the function fx equal to e to the x is called the natural exponential function. Okay, so this one is going to be the function that we use, and it's going to be the useful function in calculus. So we now know e, and we know e is about 2.71828, and it's lie between 2 and 3, and this one is going to turn out to have this graph, and this one is going to be natural exponential function. Okay, the number e can be obtained in terms of limit as follow. So you'll be able to find this limit x go to 0 of 1 plus x to the 1 over x. And this guy, after some changing of variable, we'll be able to write this guy as this guy is going to be the same limit x go to infinity of 1 plus 1 over x to the x. Okay, so these two guys will be studied when we study about the application of the derivative, and we're going to be able to show that this limit is equal to e by using the thing that called L'Hopital. Okay, so I will teach you next like a next week or something. So for this one, it's going to be the exponential function. Okay, so we're going to study this guy later. And you see that if we be able to plug in, so you're going to be able to plug in n large, like a n equal to 1, n equal to 10, n equal to 100, n equal to 10, 10,000, n equal to 1 million, and so on. So you see that we be able to approximate this number like a correct up to 5-digit decimal right now. Okay, so this guy will be the thing that I wrote on the previous page. Okay, 2.71828. Okay, so this one is the value for my number e. Why this guy is important? Because it's gonna give us the very simple derivative. It's gonna be derivative of the exponential function. The derivative of an exponential function is gonna be fx equal to e to the x, and we would want to find derivative of e to the x. So we use the definition. So we use the definition. It's gonna be limit h go to 0 of e to the x plus h minus e to the x over h. Okay, and you be able to expand this one. So you have e to the x times e to the h. Okay, so you have e to the x times e to the h minus e to the x, and you see that you be able to pull out e to the x. So you be able to pull out e to the x and e to the x. So you just pull e to the x out, and then you get you pull e to the x out, and you get limit h go to 0 of e to the h minus 1. And what is this limit? This limit turned out to be the slope of the tangent line of y equal to e to the x at 0, 1. This guy is equal to what? This guy is equal to f prime 0. Okay, so this guy is equal to f prime 0. And what is f prime 0 when the base is equal to e? We learn here that f prime 0 when the base equal to e is equal to 1. You see, this is the reason why we looking for this slope. So it means that this number turned out to be equal to 1. Okay, so let me highlight it yellow. So we know that the yellow guy turned out to be equal to 1. Okay, the yellow guy turned out to be equal to 1. That gives us our final answer. So it's going to be derivative of e to the x. Okay, so this is the final conclusion. We have derivative of e to the x turned out to be e to the x. Okay, so this one will be our conclusion. Derivative of e to the x equal to e to the x. Okay, let me conclude this one first. We begin with the problem that you like to find the slope of the tangent line at 0. Okay, when the base equal to 2, you get 0.7. When the base equal to 3, you get 1.1. And you see that for the exponential function, we're gonna have this limit to compute, and we want the simple formula. So in order to obtain the simple formula, we need the yellow number to be equal to 1. And the yellow number turn out to be f prime 0, or the slope of the tangent line of y equal to e to the x at x equal to 0. So this is the reason why we are searching for e, because we need the yellow guy to be disappear. Okay, so if it's equal to 1, it will disappear, and it's going to make our derivative very simple. Okay, so this one is going to be dip e to the x equal to e to the x. Okay, last thing that we're going to study is going to be about trigonometry. Okay, so we need to differentiate sine and cosine. So in order to differentiate sine and cosine, we're gonna study a special limit. Okay, so in order to study that limit, we're gonna take a look at this picture. In this picture, you see that we're gonna have a triangle OA. Okay, so we have a triangle OAP. So we have this triangle OAP, which is the pink one. Okay, so we have the triangle OAP, and we have the sector. You have the sector OAP. The sector mean like you have a pie or a pizza that you have some arcs AP. Okay, so it's going to be triangle, but the base of the triangle turn out to be an arc. Okay, so you have an arc AP. Okay, an arc AP. Okay, so this one is called sector. Okay, this one is called sector. So in this case, I will highlight area of OAP. So from the picture, you see that the area of the pink triangle turn out to be less than or equal to the area of the sector OAP, which is I'm gonna circle the blue color. Okay, so we have the area of the pink triangle is less than or equal to the area of the sector OAP. And we have the area of the big triangle, the gray one. Okay, so this one is the larger triangle. It's going to be the triangle OAQ, which is the most area here. So in this case, we have this one, the area of OAQ. Okay, so for computing, okay, for computing the area, we're gonna have the area of OAP, okay, the area of the triangle OAP, because P here has coordinates. So this one is, go back from your high school. So this one is the arc that has length equal to theta. So the coordinate for P turn out to be cos theta, sine theta. So it means that the height here equal to sine theta. Okay, so the height here is equal to sine theta. Okay, so it's gonna be 1/2 sine theta to be the area for the pink triangle. The next one is gonna be the area of the sector. The area of the sector come from, okay, so if I draw a sector for you, so if you have the center and you have the sector like this, and it's gonna be an arc here. uh, okay, so let me erase this one. So it's gonna be an arc and an arc here. Okay, so like this. So this one is theta. Okay, this one is theta, and this one is the radius r for a sector. And the area for this guy will be 1/2 r square theta. Okay, so this is the thing that you may have learned in high school, or if not, you'll be able to just use the area of the circle. Okay, and this one is going to be measuring the arc here, so it's going to be 1 over, like, let me, the total area of circle is pi r square. Okay, the total area of the circle is pi r square, and the theta here is gonna be like 2 pi r. So let me. So I have to draw a circle. I have to draw a circle. So area is gonna be pi r square. Area is pi r square. Okay, and it's gonna be the circumference equal to 2 pi r. Okay, so it's gonna be the circumference equal to 2 pi r. So in this case, if you don't want the whole circle, you just have an arc here. Okay, you just have an arc or a sector here. So you have the center and you would want to just find this area. Okay, so basically it's gonna turn out to be how much data that you have here. Okay, how much data that you have here is gonna measure that. Okay, and it's gonna be like 2 pi. Okay, so in this case, for the whole thing, for 2 pi r, it's gonna be pi r square. For 2 pi r, it's gonna be pi r square. Let me 2 pi r, it will be pi r square. So it's going to be theta. So it's going to be pi r square over 2 pi r times theta. Okay, so you just use the what is called the ratio. Okay, so it's going to be the ratio that you have multiply by theta, and then you're gonna see that the area on this side, the area, and the area turned out to be 1/2 r theta, not r square, sorry, it's going to be 1/2 r theta. So the area of this sector turned out to be 1/2 r theta. Okay, so that will be the area of the sector. Okay, and in this case you have the unit circle, so the radius turn out to be r equal to 1, so it's going to be turn out to be 1/2 theta. So this one will be the blue area, here. The next one will be the area of the largest triangle, OAQ. The largest triangle will have the area equal to what? You have the base equal to 1. Okay, you have the base equal to 1, and you will have the height here. The height here turned out to be equal to 10 theta. How would I have 110 theta? So this one slope. Okay, so let me explain this one. This one has slope equal to, it's gonna be using the point P here. Slope equal to sine theta minus 0 over cos theta minus 0. So it's gonna be sine theta over cos theta, and this guy turned out to be equal to 10 theta. Okay, slope equal to 10 theta, and you have this equation. So the line will have equation y equal to 10 theta times x. Okay, so this one is the slope and it passes the origin. So the plus c turned out to be equal to plus 0. And then, so this one is going to be the line y equal to 10 theta x, and you're going to put x equal to 1. When you're putting x equal to 1, you're going to get q. Okay, you're going to get q, and it's going to be this point 110 theta. Okay, so it's going to be this point 110 theta. So in this case, the area of the triangle OAQ turned out to be 1/2 tan theta times 1. So it's going to be 1/2 tan theta. So we can get rid of 1/2 from this equation. So you would obtain sine theta less than or equal to theta less than or equal to tan theta, and tan theta is sine over cosine. So you divide by sine theta, both sides. Okay, so you divide by sine theta, both sides you get 1 less than or equal to theta over sine theta over 1 over cos theta. And you're gonna flip this one up, flip this one up, flip this one up. So you would get, so this one, the side, when you flip, it's gonna change to opposite. Okay, so when you flip this one, the side will change to opposite. Less than will change to greater than. Okay, so in this case, you would get cos theta. Okay, so here you get cos theta, and here is going to be sine theta over theta, and this guy is going to be 1. This is what we obtain here. Okay, so in this case, you get cos theta less than or equal to sine theta over theta, and you get less than or equal to 1. And this guy will be the yellow function and the blue function that we study on squeeze theorem. So you have the function in the middle equal to sine theta over theta, and you have the function like that I told you before is going to be acting like a bread, and this one is going to be ham. Okay, this one is going to be the bread. Okay, so for this one you have limit theta go to 0, limit theta go to 0 of cos theta equal to 1. Okay, that we would have here. And on the other side, limit theta go to 0 of 1 turned out to be equal to 1. So finally, we be able to use the sandwich theorem to imply limit of the middle guy. The limit of the middle guy turned out to be equal to 1. So please memorize this one, limit sine theta over theta turn out to be equal to 1. Okay. Another important one that we will use is going to be limit theta go to 0 of 1 minus cos theta over theta. So in this case, we know limit sine theta over theta when theta go to 0 equal to 1. So how about this limit? This limit will be, we're going to use the trigonometric identity. So you have limit theta go to 0 of 1 minus cos theta over theta, and you have to multiply 1 plus cos on top. Okay, so you multiply 1 plus cos theta, 1 plus cos theta, and this guy turned out to be limit theta go to 0, 1 minus cos, 1 plus cos turned out to be 1 minus cos square, okay, over theta. So this is the guy that you have on top, and you have 1 over cos theta. Okay, so it's going to be 1 over 1 plus cos theta. Okay, and you see that this one turned out to be limit theta go to 0, and you have 1 minus cos square, which is the yellow guy, and 1 minus cos square is sine square theta over theta, and you multiply with the red guy, which is 1 plus cos theta. And here you'll be able to simplify to limit theta go to 0 of sine theta over theta, multiply with sine theta, and you have 1 plus cos theta. Okay, and you see that limit theta go to 0 of sine theta, so this guy is equal to 1, okay, by using the pink limit. Okay, so you use the pink limit, this guy equal to 1 from the previous page, okay, equal to 1, and you take sine theta, so it's going to be sine of 0, and you're going to multiply with 1 over 1 plus cos 0. So this guy will be 1 sine 0, 1 plus cos 0. So it's going to turn out to be 0. Okay, so you have limit. Okay, so you have this guy equal to 0. That's all. So you have this limit equal to 0. Please also try to memorize this one. This one also important. Okay, so this limit equal to 0. Let me highlight this one as the blue limit. So this guy equal to 0. Okay, 1 minus cos theta equal to 1 minus cos theta over theta, limit equal to 0. Why these two guys is important? Because we like to find derivative of sine and cosine. Derivative of sine x, okay, is the definition. By using the definition, we would get limit h go to 0 of sine x plus h minus sine x over h. And sine x plus h turned out to be sine x cos h plus cos x sine h. This one come from trigonometry formula identity. Okay, and you see that you'll be able to simplify this one. Okay, so you're gonna group sine x together. You have this sine x and you have this sine x, so you're gonna group it together. So you're gonna get sine x and 1 minus cos h over h, and you have the second term. You have the second term, which is cos x sine h. Okay, and you're gonna have sine h over h, sine h over h. So this guy will be sine h over h. Okay, so this is sine h over h, and you have 1 minus cos h over h. Okay, 1 minus cos h over h, and sine h over h is the pink limit. Okay, so it's the pink limit. It's going to turn out to be equal to 1. And 1 minus cos h over h, h go to 0. This limit is the one that we studied on the previous page, and the limit equal to 0. So in this case, you would obtain the formula dip sine equal to cosine. Okay, so you have dip sine equal to cosine. And in a similar way, you dip cos. Okay, so you dip cosine, you use the same formula. It's going to be cos of x plus h minus cos x over h. And the cos of x plus h turn out to be using the trigonometric identity cos x cos h minus sine x sine h. Okay, and then you're gonna group this one. So you have cos x cos h minus cos x. Okay, so in this case you have cos x. Sorry, let's do it this way. So you have cos x that I can group it together. Okay, and you have sine h sine s sine x sine h. Sine x sine h is this term. Okay, and you also see that this guy you would get sine x sine h. Okay, and the same thing happen here, 1 minus cos h over h. So for this one, you get 0. So this one is going to be 1. This one is going to be 0. And you have negative sign come from this negative side. Okay, so you have this negative side, negative side, negative side. So you dip cos, you get negative side. Okay, dip side, you get cos, dip cos is negative side. Okay, so please try to memorize this one. I know that you have the formula sheet for exam, for exercises, but it's going to be very clumsy if you don't know how to dip sine, dip cos. Okay, and that one will be important. Okay, so we learn like dip constant equal to 0, dip x to the r is r, x to the r minus 1, dip e to the x is going to be e to the x, dip sine equal to cos, dip cos is negative sine. The limit x limit sine x over x we can further have. Okay, so for we know how to find limit x go to 0 of sine x over x. This guy is equal to 1, right? Let write 1. So this guy is, we know that is equal to 1. We can further have, when you have sine of fx over fx, sine of fx over fx. So if you have sine of something over that thing, okay, it is the same term. So you have sine fx over fx. It's going to turn out to be equal to 1, okay, if the limit of the green guy is equal to 0. Okay, so if you have sine of the term over the same term on the bottom, and that term has limit go to 0, the limit of sine fx over fx turned out to be equal to 1. Okay, that's what you can answer. Let's take a look. So you see this one is quite simple. You have sine x minus 1 over x minus 1, and this guy is the same term. So this guy is your fx. Okay, so this guy is your fx automatically. So it's going to turn out to be 1 without any calculation. Or you may say it's because limit x go to 1 of x minus 1 equal to 0. The next one will be limit x go to 0 of sine 3x over x. So you see that you have the green one, 3x, but on the bottom, you don't have the green one yet, you have only x. So we're going to play the trick. So you're going to multiply 3 here, and you see that, hey, we obtain the green one, right? So we obtain the green one already. So when we multiply by 3 on the bottom, you're going to multiply by 3 on top, okay? So you see that this will allow you to have the limit equal to 1 times 3, and 1 times 3 equal to 3. Okay, so you get the limit equal to 3 for this limit sine 3x over x. Okay, I gonna rewrite this thing because I lose the originality here, so I don't want to. So it's gonna be limit x go to 0 of sine 3x over 3x, and you see that I can write this one clearer. So I multiply 3 here, divide by 3 here, and this guy will turn out to be my green guy, okay? And this limit turned out to be equal to 3, okay? So I didn't lose anything in the question, okay? I want you to see the question, that's why I rewrite this thing. And you see that the reason here is going to be limit x go to 0 of 3x equal to 3 times 0 equal to 0. Okay, the limit of the green one must be equal to 0. The next one, you see that this guy is gonna be limit of sine x minus 2, and you have x squared minus 4 that can be factored as x minus 2, x plus 2, and you have limit x go to 2. And you see that it's going to be limit x go to 2 of sine x minus 2, x minus 2, 1 over x plus 2. And you have this one, okay? And you have this one, okay? And this limit turned out to be equal to 1, okay? This limit turned out to be equal to 1 because you have the green one here, and the limit of the green one turned out to be equal to 0. Okay, limit x go to 2 of x minus 2 is equal to 0. So in this case, it's gonna be 1, and you're gonna have this limit turn out to be, this limit is equal to 1. Let me write it here. So this guy is equal to 1, and the final one will be, okay, so this guy will be limit x go to 2, so it's gonna be 1 time 1 over 2 plus 2, so it's gonna be 1/4. Okay, so this one will be that. Last one, you have limit x go to infinity of sine of x sine 1 over x. So in this case, you see that the green guy turned out to be 1 over x, and you would need 1 over x. So in order to obtain 1 over x, so you're gonna move. So it's gonna be limit x go to infinity of sine 1 over x over 1 over x by moving x down to the bottom. So you see that it's going to be the green guy and the green guy now. And we learn that limit x go to infinity of 1 over x turn out to be 0. So this guy is the limit of the green guy. So in this case, you have this limit turn out to be equal to 1. Okay, and that is going to be all. Okay, so this one is the not fancy one. So I'm gonna do another 2 example, or maybe 3 example on the fancy limit like this. Okay, that we still need the trick of sine the green guy over the green guy. Okay. Okay, the next one, you like to find limit x go to 3 of sine x minus 3 on the bottom, and you have square root of x squared plus 7 minus 4. When you plug in x equal to 3, you get 4 minus 4 and sine 0. So for sure, it's going to turn out to be 0 over 0. So you need to simplify. So in this case, you have limit x go to 3, and you have square root x squared plus 7 minus 4 over sine x minus 3. And you multiply this guy. So you multiply square root x squared plus 7 plus 4 over square root x squared plus 7 plus 4. And you hear that it's gonna be limit x go to 3, okay, and you're gonna multiply the top one, so it's gonna be this term and this term. Okay, so in this case you would get x, you would get x squared plus 7 minus 16 for the numerator, and on the denominator you get sine x minus 3. Okay, and this one will be square root x squared plus 7 plus 4. Okay, and then this one will be limit x go to 3. Okay, and this guy turned out to be x squared minus 9, and x squared minus 9 can be factored as x minus 3, x plus 3, and you have sine x minus 3, and you have square root x squared plus 7 plus 4. And you see that you can have the green one. Okay, you can have the green one like this. You may argue with me a little bit that, hey, it's not the same yet because it must be sine something over. Okay, so it must be sine over sine something. So it's not that yet. It's not that yet. You may flip. So it's going to be x equal to 3. Okay, and you have x plus 3 on top. Okay, and you have sine x plus 3, and you flip x plus 3 down, and you would multiply with square root x squared plus 7 plus 4 like this. Okay, and you see that this one will give you the green one and the green one. Okay, and this limit turned out to be equal to 1. Okay, so this guy turned out to be equal to 1. Okay, and you'll be able to obtain the final answer. So it's gonna be 3 plus 3, and you have the limit 1 here, multiply with square root 3 square plus 7 plus 4, and this guy will be 6 on top. Okay, and you get square root 16, so it's going to be 4 plus 4 on the bottom, so it's going to be 3/4 for final answer. Okay, so you have 3/4 for final answer in this case. Okay, so this one will be the limit x go to 3 of the fancy one that you need to like multiply to get rid of the square root, and you be able to obtain the desired limit. You have the next one will be tan 2x. Okay, it's going to be tan 2x over x squared plus 2x. Tan 2x, what is tan 2x? Tan 2x turned out to be sine 2x over cosine 2x, right? So this guy is going to be limit x go to 0, and it's going to be sine 2x. Let me write this one smaller. Sine 2x over cos 2x, and you multiply with x squared plus 2x. Okay, so this one is your tan 2x. Okay, this one is your tan 2x. And you see that x squared plus 2x, I don't need x squared plus 2x, I need x multiplied with x plus 2x. And you see that we can have the green one. Okay, the green one in this case is my 2x. So we need another green one here. Okay, so in order to get that green one, I'm gonna need 2 here, and I'm gonna have to multiply 2 on top. Okay, so you have 2 on top, 2 on the bottom. So you would get limit x go to 0 of sine 2x over 2x. So this one are the green one, 2x and 2x. And you have multiply with 2 over cos 2x. Okay, so this one is going to be over cos 2x. And you have 1 over 2x left. Okay, so you have 1 over x plus 2, not 1 over 2x. Okay, so you have this limit equal to 1. Okay, you have this limit equal to 1, and you take x go to 0. So you take x go to 0, so it's gonna become 2 over cos 0. Okay, plus, not plus, multiply with 1 over 0 plus 2. Okay, so in this case, it's gonna be 2 over cos 0 is gonna be 1, right? Let me write it here. So this guy is equal to 1 first. So basically, it's gonna be 2 over 2, and that will give you equal to 1. Okay, so that's all. The next one, okay, so the next one will be 1 minus cos square, okay, something kind of fancy, 1 minus cos square, and you have something over 4y square minus y. This one seems hard, but it's not that hard to do. So this one is gonna turn out to be limit y go to 0, and 1 minus cos square is going to be just sine square, right? So this guy will be sine square y. And you have this one, and you'll be able to pull y square out. So it's going to be 4 minus y. And you see that this one turned out to be sine y over y square multiply with 4 minus y. Okay, so this one can be written into this form, and it's now turned out to be very simple. Okay, so you take the limit. You take the limit, it's gonna turn out to be 1. Okay, multiply with 1 over 4 minus 0. So it's gonna be 1/4. Okay, so this one will be another limit that quite simple. The trick that I like to teach you here is going to be just you have to be able to see this guy as this guy. Okay, so that is going to be the trick that I would want to present to you in this example. Okay, last one. You have limit x go to 0 of sine 2x over 3x minus 10x. Okay, sine 2x over 3x minus 10x. And in this case, you would get, okay, so you have this one. So in order to do this one, you may need to know one identity. Sine 2x, okay, sine 2x, it is equal to 2 sine x cosine x. Okay, it is equal to 2 sine x cosine x. So in this case, it's going to be limit x go to 0 of 2 sine x cosine x over 3x minus tan x is sine x over cos x. Okay, so you see the structure of the function. It's going to be 2 sine x cosine x on top that I will highlight the pink one. Okay, and you have tan x equal to sine over cosine. Okay, and we know limit x go to 0 of sine x over x equal to 1. This is what we know. We don't have sine x over x yet, but we can make it happen. So we're gonna just multiply the top by 1 over x, the bottom by 1 over x. And you see that it's gonna give you many sine x over x. So it's gonna be, let me use other colors would be better. So it's gonna be limit x go to 0. And on top it's gonna be 2, and you have sine x over x. Let me use the red color here. And you have cosine x on top over. You have 3x over x minus sine x over x 1 over cos x. Okay, so this is how we have, and you see that it's gonna be limit x go to 0, and you have sine x over x. Okay, so you have sine x over x that the limit equal to 1. Let me circle this one. Okay, sine x over x and sine x over x. And you also be able to get rid of x and x here. Okay, so it's gonna be 2 times 1, 2 times 1 times cos 0 over 3 minus 1 times 1 over cos 0. And this one turned out to be, uh, 2, okay, on top, and 3 minus 1 on the bottom. So it's going to be 2 over 2, and 2 over 2 will be equal to 1. Okay, so this limit is equal to 1. It's kind of tricky that you need to know many identity. I know, but this one is the last question. It must be the most difficult one. So you have sine x, and you need sine x over x to have the limit equal to 1. Okay, so you need sine x over x to have the limit equal to 1. So you multiply 1 over x on top and 1 over x on the bottom to create this term and this term, and this one will be the whole thing. Okay, so what have we learned in this lecture? It's going to be this special limit sine theta over theta. Okay, and it's going to be derivative of sine and derivative of cosine. Dip sine is cos, dip cos is negative sine. Okay, so this one is going to be in this lecture. And we learn about dip constant, dip exponential, dip power function as well. Okay, so we're going to continue next time about derivative formula, about dip of the sum, the difference of the function, the product rule, and the quotient rule. Okay, so that what will happen next.